This video goes over how to create your own procedure to calculate points which are in a Mandelbrot set and how to display the results. It's astonishingly easy. Let's get started. We begin by noting that we're going to be working on the complex plane. So there's the real axis, this is the imaginary axis, and we're going to consider points on this complex plane, which is defined by their real and imaginary components. The idea is that a point in the complex plane is part of the Mandelbrot set if it stays within a region, as designated by R, some radius, after we apply a function to it an infinite number of times. So the function being that we're going to take whatever point we have, okay, and we'll call it C, and we'll designate it to Z0. And then what we're going to do is we're going to ask, are you within this region of red? And then what if we square it and add back the original value? Is that number, which might be over here or here or here, complex number, is that still within this region? Is its absolute value still less than what's called the breakout radius? We're going to apply this supposedly an infinite number of times, and if it stays within the region, it is part of the Mandelbrot set. Now obviously you can't apply it an infinite number of times, so we'll designate some maximum number of iterations we're going to apply this function. So here is the programming calculation necessary to determine if our point is within the set, or really how many iterations do we have to do in order to see whether it either breaks out or it doesn't. So we're going to pass it our value. Our original value is C, and that's what we're going to designate as Z is. We're going to pass it some value of the maximum number of iterations that we call infinity, and we can in Maple default that to 100 so that if it's not passed, it already has a value. And we will designate where is this radius of breakout, i.e. what is the absolute value of Z for which it must stay within. So we have our counter I, and what we're going to do is we're going to loop from 0 to the maximum values. But we have a way of stopping the process, which is quite unique in any of these programming languages, in that we can add the while. Everything is hunky-dory, keep on looping, as long as the absolute value of Z is less than our breakout radius. As long as we're doing that, and then we apply the function Z squared plus our original C, and we assign that to our Z value and repeat the process. So I goes from 0 to max iterations. Keep checking. As long as this is true, keep iterating I. And when you get to the end, we've either broken out with an I value less than the maximum, or we return with the maximum, and that's what this expression is here. So we're going to test this. We're going to use 500 points, and the way we're going to work this is we will define a bottom left of the region that we're going to be looking at. So in a rectangular region, so the bottom left, that's Z bottom left, and an upper right, Z upper right. This makes it consistent with the Fractal Tools package that's already in Maple. Our maximum number of iterations will be 50, and our breakout radius will be 2. We're ready to actually plot. We're going to do a density plot, part of the plots package. We're going to call this procedure called the Mandelbrot set. We're going to pass it again the Z component, which is Z value, which is X plus I times Y. The maximum iterations are a breakout radius. You'll note that we put a single quote around this to make sure that this doesn't get passed before it is a chance to be calculated. X is going to go from the bottom left-hand side to the upper right-hand side, but only the real components. Y is going to be from the bottom left to the top right. Again, only the imaginary components. We'll make a grid that is 500 by 500, no axes, and we'll use a color scheme reverse turbo. This tells us it takes about 5.5 seconds in real time, almost 6 seconds to calculate. And here is our fantastic image. And since it's in a density plot, we can see along the lines where we had no iterations before it broke out to our maximum number of iterations. So all this black area in with here are members of the Mandelbrot set. There's more to the worksheet on working with Mandelbrot set, including a compiled version of the procedure and how to make matrices from it, and in fact, in the end, of course, plotting those matrices. But I'll leave that for another video. This process was so astonishingly easy. I spent hours trying to manipulate Python to get it to work with Maple, because I just assumed it had to be more complicated.